Okay, so following on from last video, we started to introduce types of errors. So I'm going to let you just read through this. I'll just go over it really quick. Type 1 error is me rejecting the null hypothesis when the null hypothesis is true. Okay, think of that line I was doing with you. In our example, with the quiz one that you did, it would be saying that you are an expert when in actual fact you were just guessing or you just didn't have any knowledge of it. Type 2 error is the other way around. So when we do not reject the null when there is another value for p. Okay, so it's like me saying that you were guessing those values, but actually you are an expert. Okay, so what we'll do is just go through two examples just to see if we can iron things out with that. It's not easy at all. I'm sure I said that before. Let's have a look though. So example 4, because this is following on from the previous video. Machine produces smartphones. Previously we see it's 7 in every 200. After the machine was accidentally moved, the technician suspects that the amount of faulty parts has increased, and you're going to get a random sample of 85. So null hypothesis, is that 7 in 200 or 0.035? We want to see that if it's increased, so greater than. Now the technician decides that the critical region, so when he's rejecting the null hypothesis and saying that it has increased, should be greater than or equal to 5. Alright, so 5 or more of those 85 parts come out as faulty, then the machine's gotten worse, isn't it? It's increased the amount of faulty parts. After checking those samples, she finds it's 4. State conclusion. Okay, so conclusion. Remember, critical region is where I'm rejecting HO. The 4 parts are faulty does not lie in that. Okay, so it's not inside the critical region CR. Therefore, we wouldn't reject HO. We'd still say that the probability of a faulty part is still 0.035. Explain what a type 1 error would be here. Okay, so a type 1 error would be the probability of me rejecting HO when HO is true. So if I reject the HO, I'm saying H1 is true in a way. So in this context, I would be saying type 1 error is me saying that the number of faulty parts has increased when in actual fact the amount of faulty parts is still 0.035. The probability of this, right then, well, I reject the HO when I'm inside the critical region, and in a type 1 error I am rejecting the HO. So I want to know the probability of me being in the critical region, and the critical region was x greater than or equal to 5 when HO is true. So I'm still using HO as being 0.035. Okay, and it should come out as this 0.01775. D. Oh, sorry, you've seen the answer for this, but let's go through it. If the technician wanted a 5% significance level, what would the critical region be? So remember, critical region, type 1 error are similar to where I'm rejecting the HO. So I want to be rejecting the HO 5%, and I need to find some value here. So I've done some trial and errors, and I've seen that if I'd work out the probability of x being greater than or equal to 6, it's about 8%. Greater than or equal to 7 is about 3%. Now you'll notice neither of these give me the 5%. Because it's a significance level, if I'm above it, I'm not going to be rejecting HO. So I want to be below the 5%. So I'm actually going for the greater than or equal to 7. Now if I wanted to work out the type 1 error here, the type 1 error here is the 0.02964. Okay, and that's where significance level and type 1 error can be different. They don't have to be the same probability, but we're thinking in the same way. Okay, so it's a bit of a strange one, that. But hopefully kind of makes sense. I've still got a 5% significance level, because that's what I'm stating. Okay, that's my you know, 5% is sort of my accepted probability of being making an error. Okay, that's what I'm stating. The type 1 error is the actual probability of that happening. Okay, 5% is more of a sort of I want to be about that, and then the type 1 error is the actual calculation for it. So one more example. A manufacturer of cereal states that 25% of the packets contain a gift voucher. They buy 50. They assume that the proportion P. Okay, so they're given this hypothesis here. They think it's more than 25%. They're giving us a critical region. And they want us to calculate the significance level of this procedure. So all I need to do here is remember significance level is rejecting the HO, so being in the critical region, which is x greater than or equal to 18. I've got the n as 50, p is 0.25. Hopefully that will make sense to you. What I'm more interested in is part 2. What's the probability of drawing the correct conclusion if the value of p is actually 0.3? Alright, let's make sense of this. I know p is now actually 0.3, so it's not the 25% from earlier, it's now 30%. Now that means I actually want to be saying that h1 is greater than 0.25, because I know p is actually greater than 0.25, and we need to make a correct conclusion. So I need to reject the HO. So rejecting the HO when x is greater than or equal to 18. But what's really important here and what's different from the first part is my p is now different. P is 0.3. Yeah, because I know p is 0.3. But I still need to make a correct conclusion, which means I need to reject it, which is why I'm still looking at the critical region. And that comes out as 22%. Okay, so you've got to stop and think, what am I doing here? Not easy at all. Okay? Any questions, pop me an email.